What's this called? It's a parabola, right? More specifically, what is it called? Okay, so if I say parabola is the right answer and then I ask for a more specific answer, you can't say exactly the same answer. It is a quadratic, I agree with that. More specifically, what is it in relations to a quadratic? It is. Okay, it's the parent function. What does the parent function look like on a graph, on a coordinate plane? Where's the vertex? 0, 0. If I go right 1, I go up 1 because 1 squared is 1. If I go right 2, I go up 4 because 2 squared is 4. If I go right 3, I go up 9 because 3 squared is 9. Are you guys okay today? You're acting super weird. Do I have to go through the whole same pattern in my head for this? I mean, I can, but it's symmetric, right? If it's symmetric, can't I just kind of draw these in over here, knowing that the same pattern is happening? So when I ask you if a parabola is parent function shape, I'm asking you, is it this shape right here? What's going to make it this shape right here? No matter where I move it, no matter where the vertex, it stays parent function shape if it's x squared, right? If it's 2x squared or 3x squared, that's not parent function shape anymore, right? But I should be able to ask you, or I should be able to move this around anywhere on the graph based on transformation rules, right? So if I say y equals x minus 4 squared plus 6, where is this vertex? So where's the vertex? 4, 6. So I should be able to go over 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And still draw the parabola without having to go in my calculator and look at the table or create a table on my own, because I know this is parent function shape because there's no multiplier in the front. So from the vertex, I should be able to go over 1, up 1. Over 2, up 4, and over 3, up 9 if I could, right? It just doesn't fit on this graph. Over 1, over 2, up 4. It's the same shape as the parent function. It's just moved somewhere else on the graph. Do you see what I'm saying? You know, there's sometimes when we've done graphing with quadratics before, and it was good enough to know where the vertex is, and then we just drew it, right? Today is not one of those days. Today we really need exact points because of what we're doing. All right? So I'm trying to get you to realize that if it is parent function shape, we already know what that shape is, no matter where the vertex is, and I can just draw it. Over 1, up 1, over 2, up 4, over 3, up 9. Over 4, up 16 if there's room, right? So what happens if it's not parent function shape? Well, it's really not that difficult. You just have to think about it for a second. What if it was y equals 2x squared? Well, where's the vertex? 0, 0. Instead of going over 1 and up 1, I'm still going to go over 1, but I'm going to go up 2 times 1. So up 2. Instead of going over 2 up 4, I'm going to go over 2 up 4 times 2. So 8. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. I could go over 3 and up 18 because that's 9 times 2. I just don't have enough room on my graph, do I? Again, I know it's symmetric, so I know we can just draw those points in. I don't have to know exactly what point it is. It's good enough that I know what the shape is. Do you understand what I'm saying? I don't have to draw a table to know exactly that this point is 1, 2. And with the vertex at the origin, it's not really that big of a deal. Okay? But what if it looks like this? Y equals, ooh, I'm going to trick you also at the same time. Is that all right? Or try to trick you. So let's do this one. Where is the vertex, first of all? 7, 4 is the vertex. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. What's my multiplier? My multiplier is 3, right? The negative tells me what? It's opening down, okay? So that's where I was going to try to trick you. I failed. Dang it. So instead of going over 1 down 1, I'm going to go over 1 down 3 because 1 times the normal 1, which I would do, times the 3 that's the multiplier. Instead of going over 2 down 4, I'm going to go over 2 down 4 times 3. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Instead of going over 3 down 9, I would go over 3 down 27. 9 times 3. I can't do that on my graph. There's not enough room. So I've just got this shape. Do you see what I mean? I don't have to care that this point is 1, 2, 3, 4, 5, 6, 7, 8, 1. I don't have to know that. I have to know compared to the vertex, it's over 1 down 3. Does that make sense? Can you, if you're confused about this at all, can you put this into your equation or into your calculator as an equation and go Control T to look at the table and plot those points? Absolutely, without a doubt. I'm trying to teach you a shorter way that works every time. Is that fair? Okay, now are you ready for the actual lesson for today? I just had to get this out of the way first, reminding you about parent functions, reminding you about vertex form, showing you about how to graph stuff like this so that we get to today's lesson. We good? Okay, so here's today's lesson. Or the first part of it. So what's different? Okay, so the inequality is going to have me do several different things, right? What is one thing that it's going to have me do? Shade, for sure. I'm going to have to shade, right? Because if I have a less than or greater than or less than or equal or greater than or equal, there's not just one answer. There's multiple answers that could be true, so we show that by our shading. Okay? What else am I going to have to be careful of? Dotted or solid. Okay? I'm going to have to decide by looking at the inequality sign if it's dotted or solid. Can we write ourselves a little note right down here? If it's less than or greater than, what kind of line is it? Dotted. Oh yeah, remember the argument we had last time? Or dashed. Either one is fine. Weirdos. Less than or equal, greater than or equal. Solid. Ha. Okay, so far? So how am I going to graph this? Using transformation rules. What happens to the parent function? Up 6, right? So from the vertex, 1, 2, 3, 4, 5, 6. That's my vertex. Now, here's the fun part. Is it parent function shape? So from the vertex, I'm going to go over 1, up 1. Over 2, up 4. Because 2 squared is 4, right? Over 3, up 9, but I can't. And again, it's symmetric, so I already know what the other side looks like. Now, is this a solid line or a dotted line? Solid. And I'm saying line, and I shouldn't say line because it's not geometry definition of a line, because line in geometry by definition is straight, right? So this is like a curvilinear, or it's a curve, or it's a parabola. You know what I'm saying, yes? Okay. I just don't want to confuse you by using bad vocabulary. Is that fair? Okay. Am I done? No, I have to shade. How do I decide where to shade? So for lines, it was easy, because if it was greater than, it was above. If it was less than, it was below. So I'm only going to end up showing you 1, 2, 3, 4, probably 4 examples, maybe 3 examples of that today. So that's really not enough to be able to say one way or the other, like for us to decide from 3 examples if it always works. So what if we don't have something like that? Let's figure out a way to decide where to shade. How did we decide before if we couldn't remember the greater than, above, less than, below? Yep, we chose a point. I need to know if this point makes this inequality true or false. If it makes it true, I shade where the point is. If it makes it false, I shade the other place. Again, before we had above and below, what do we have this time? Inside and outside. That's exactly right. Okay, inside and outside. So if we plug in 0, 0, substitute 0, 0 in here, I get 0 is less than or equal to 0 squared plus 6, which simplifies to 0 is less than or equal to 6. So that's a yes. Because it's a yes, I shade wherever that point is. Where is that point? On the outside. So I shade on the outside. So where are all the possible solutions to this inequality? Everywhere that it's shaded, right? So someone give me one possible solution to this inequality. 3, 2. 1, 2, 3, 1, 2. 3, 2. Is that a possible solution? So possible. Somebody else give me one more. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Is that a possible solution? Awesome. What about 1, 7? Is that a possible solution? 1, 1, 2, 3, 4, 5, 6, 7. It's right there. It's possible because it's on the line. And the line is solid, so that is a possible solution, isn't it? Solid lines are part of the solution. Dotted or dashed lines are not part of the possible solution, because it makes the inequality not true. Okay? Okay so far? Do I need to show you any more like this? No? Okay. Feeling confident, are we? Awesome. So what about this one? Uh-oh. What does it just become? A system. It's a system of inequalities. Do we still have to worry about dotted and solid? Yes. Do we still have to worry about shading? Yes, but we're going to shade where both of them are true. Not just one, not just the other, right? Now, some of you, when we did systems of systems of inequalities, like linear inequalities, you would shade both of them, and then wherever the darker shading was, you knew that was the answer, right? Some of you that confused, and so I said, just draw arrows on the line to where you would shade, and then when you get both of them drawn, then actually go do shading. I don't care which way you do it. Whichever way you're more comfortable with is what I want you to do. Okay? I get confused with a bunch of shading. So I'm going to draw arrows where I would shade and then shade when I'm all the way done. Are you okay with that? Okay. So I'm going to graph the first line in red. And if you are a visual learner, this is a good time to take out the colors and do one line in one color and one line, or one curve in one color, one curve in the other color, because it makes it less confusing. If it doesn't matter to you, I also don't care. Okay? But especially visual learners, colors help at this point. Okay? So let's take care of the first curve first. How do I graph the first one? Up 3. And then what? Parent function shape, so over 1, up 1, over 2, up 4, over 3, 6, 7, 8, up 9, right? Is this, excuse me, solid or dotted? It is dotted, dashed. I'm not going to fight with you about that. And would I be shading inside or outside? Well, I'm going to choose 0, 0. 0 is less than, 0 squared is 0, plus 3. 0 is less than 3. That is true, so I'm going to shade toward the true side. So I would shade outside of this parabola, like that. So I've taken care of everything with that curve. God bless you. Taking care of everything with that curve, right? So I'm going to do the other curve in blue. How do I graph this one? 1, 2, 3, 4, 5, 6, 7, 8. And then opens down, but still has parent function shape, right? So over 1, down 1, over 2, down 2, 3, 4, and over 3, 5, 6, 7, 8, 9. Uh-oh, over 4, 10, 11, 12, 13, 14, 15. I got room for that one, so I need to put it on there, don't I? Is it solid or dotted? It is solid. Why is it solid again? Or equal to, right? Okay. And should I shade inside or outside? Uh-oh, I missed a dot. My dots are wrong. I missed a dot. If you're looking at mine, just be ashamed of it because I missed a dot. There. Not. So again, I would choose 0, 0. 0 is greater than or equal to, negative 0 is just 0, plus 8. 0 is greater than or equal to 8. This point for the blue parabola is not true, so I would shade outside. So where would I end up shading when I actually do my shading? So all this, and then all this, right? Somebody tell me one possible solution. Somebody who hasn't answered yet. Thank you. Thank you. 3, 6. Does that work? Okay. 6, 4. Does that work? Is there any other places that a solution could be? Oh, on the other side, right? These could be solutions over here too. So what about negative 5, 0? I can't even count. 1, 2, 3, 4, 5. Can I try to trick you? Is this a possible solution? I'm asking. Can I graph that on this graph? No, not on this graph, right? But is it going to be in the possible solution? Yes, for sure it is. Okay? So that's called predicting. It's not something you can see on a graph. You're having to predict without being able to see it. That's higher level thinking skill, believe it or not. Okay? So good job. Ready for another example? One more. Okay. I'm also going to try to trick you again. What do you want to do? Okay, so you want to move everything to one side? I'm okay with that. Can we do it this way? X squared minus 6x minus 5 is less than or equal to 0. What's wrong with this one? There's no y. So am I going to graph the answer on this xy coordinate plane? No, I am not. You want to factor it? Okay, tell me what multiplies to be negative 5 and adds to be negative 6. Negative 6 and positive 1 do not multiply to be negative 5. So nothing, right? So what other options do we have if I'm trying to solve this? Probably quadratic formula, right? X equals negative b plus or minus the square root b squared minus 4ac all over 2a. 6 plus or minus the square root of, well, we can do this in our head. 36 minus a negative 20, so 56. Is that what you guys got? Is that simplified as far as it can go? Is 56 divisible by something I know the square root of? I don't know the square root of 2. Oh, 4, right? So this would be 56 is really 4 times 14. So I get x equals 6 plus or minus 2 square roots of 14 over 2. Is 14 divisible by anything I know the square root of? No, so that's as simplified as that can get. Is this answer as simplified as it can get? What can I do? So 3 plus or minus the square root of 14. Since all three of these are divisible by 2, I divide them all by 2, right? Does this answer make sense to us in this situation? No. I need 3 plus the square root of 14, 6.74, and I need 3 minus the square root of 14, negative 0.74. Because here's what I have. Yeah, we dropped it off because we were solving it with the quadratic formula. I found x now. I have to go back to figure out what's happening up here. Okay. So here's what happens. I solve for x. What that gives me on a number line, not a coordinate plane, but on a number line, it gives me 2 boundaries. Okay. It gives me negative 0.74 and it gives me 6.74, and 0 is like right there, right? What I need to figure out is, are my answers between these two, or are they outside of these two? Well, how do I decide? Find 0. 0 squared, substituted into the original equation. 0 squared is 0, less than or equal to 6 times 0, which is 0, plus 5, which is 5. Is 0 less than or equal to 5? Yes, so my 0 is part of my solution. So am I shading between my answers or am I shading outside my answers? Between. So do you realize that there's still graphing and shading even on this problem, even though there's no y? Okay, so my graph helps me get my answer. My x is less than. Well, is it less than or is it less than or equal? What was the original problem that was given to us? Less than or equal to, it's less than or equal to 6.74, and it's greater than or equal to negative 0.74. Some people can go from here straight to the answer and then they graph it. Some people go from here to the graph and then they write the answer. Either way, both of those are your answer. Does that make sense? This is the inequality that you get as your answer, and this is the graph that shows the inequality. But both of them are part of the answer. Any questions? Okay, so in your homework, in your workbook tonight, you have 1 through 6 and 10 through 14. 1 through 4 are just matching. So you're just writing the answers in the book. Okay? 5 and 6, this graph paper is going to be much easier to use than the graph paper that's in the workbook because it's like this big. It's very tiny. Okay? 10, 11, and 12, you're also going to want to use this graph paper. That's why I gave everybody an extra one. Okay? And then 13 and 14 are like these that we just did right here. Any questions?